So now that we've studied arithmetic sequences, let's take a look at geometric sequences. Okay. Whenever it says geometric, that means to multiply. So we're not going to add something, we're going to multiply by something, multiply by something. A geometric sequence is a sequence whose terms differ by a common ratio. So we're not talking a common difference, we're talking a common ratio. And we're not going to use the letter D, we're going to use the letter R. So you're going to multiply by something, multiply by something. Remember, when we say recursive, that means previous. Okay, so we're going to write a recursive formula for a term. Whenever it says term, that means A sub n. So to find a term, let's take the one right before it, A sub n minus 1. And you take that term, and you're going to multiply it by something. And R stands for the common ratio. And that's how you make a geometric sequence. Okay, is this sequence geometric? So what you could do is just kind of look and think about what they multiplied by. It looks like the numerator stayed the same, but it looks like the denominator got multiplied by something. It looks like the bottom got multiplied by 3, times by 3, times by, oh wait, that's not times by 3. Oh, I was thinking that the ratio is going to be 1/3, but it's not. This is a trick. This one is not geometric. Remember, it has to be arithmetic or geometric for the entire list. Okay, let's see if the next one's also tricky. Well, sometimes it helps to look over here to see if you could figure out what happened. From a power of 1 to a power of 3, it looks like they got multiplied by 10 squared. Was this 10 squared? 2 more 10s? 2 more 10s? Yes! Yes, this one is geometric. The R is 10 squared. Okay, if so, let's write a recursive formula. Okay, so A sub n is take the previous term. And how do you say previous? If this is n, the one right before it was A sub n minus 1. And for this sequence, we need to multiply by 10 squared. Or you could say 100. All right, let's take a look at these. 3 times 2, 6 times 2, times 2, times 2. Yes, yes, this one is definitely geometric because the R is 2. Okay, let's write a formula then. How do you find a term? For this sequence, take the one right before it, A sub n minus 1, and multiply by 2. And that's how you write a geometric recursive formula. Okay, let's examine this right here. This is a geometric sequence, 1 times 2, 2 times 2, 4 times 2. Okay, so what's the common ratio? R equals 2. Okay, let's find the next 3 terms. Let's keep going. 8 times 2 times 2 times 2. Sometimes it helps to label this. Whenever I have a sequence, this is A number 1, A number 2, A number 3, A number 4, A sub 5, the 6th term, there's the 7th term. Okay, find the 10th term. Okay, 8, 9, 10. So we need to keep multiplying by 2. So if you need to use a calculator, 64, I like to push enter, then say times 2. Because that command, answer times 2, will keep happening if I push enter. So we've got 128, 256, and 512. Okay, so A sub 10, the 10th term is 512. So how many total R's, how many 2's do we actually multiply by to get all the way there? So the first one doesn't get a 2, but I multiplied by 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. I needed to multiply by 9 2's to get there. 9 R's 9 R's. That's weird. Again, to get to the 10th term, you only need 9 R's because the first term doesn't get multiplied by 2. Okay, let's use the trick to get to the 20th term. How many R's would you need to get there? Well, you wouldn't need 20, we would need 19 R's. Okay, so to find a sub 20, you would take the first one. So let's take 1. Let's take 1. And I'm going to multiply by 2 by 2 by 2 by 2. How many 2's? 19. That's 2 to the 19th power. And 2 to the 19th power is? A sub 20 is, wow, 524,288 is the 20th term. Okay? So let's practice that technique a little bit here. Write a formula using A1s and R's. So the technique for these, to get to the 9th term, you would start with the first one, A sub 1, start in the beginning. And then you're going to multiply by R. How many R's would you need to get to number 9? You would only need 8. To get to the 18th term, start with A number 1 and multiply by R by R by R how many times? To the 17th power. Because the first one doesn't get the ratio, only all the other terms. A sub 7 would be A sub 1 times R to the power of 6. And to get to the 67th term, you would start in the beginning, A sub 1, take the first one, and you would multiply by R 66 times to the power of 66. Okay, same technique as yesterday with arithmetic, except now we're multiplying. So that's why it's to the power of, because it's times by times by times by times by. Okay, so whenever it says explicit, this is the more powerful one, of course. Explicit uses the first term. Okay, so this is the one you're going to use most of the time. The explicit formula for a term, A sub n. How do you get to a term? Term is A sub n. So you start in the beginning, A sub 1, and then you multiply by R. But how many R's would we need if you wanted to get from 1 to n? Would you need n R's? Not quite. You don't need n R's, you need n minus 1. That is the formula for a geometric term. Okay, let's look at some examples here to see if these are indeed geometric. So what are they multiplying by? Looks like the numerators are 3's. It looks like the denominator here got multiplied by 2, by 2, by 2, by 2. Is it 2 throughout? Yes. Yes, this is definitely geometric because the R is 1 over 2. Okay, if it is, write an explicit formula. Okay, A sub n is, give me the first term. This sequence has 3 halves. And then R is 1 half to the power of n minus 1. Now, just like with the arithmetic formula, you have to simplify this. I'm going to show you how. Once you do it a couple times, you're going to get the hang of it. So please pay very close attention. How to simplify. Okay, how to simplify. We're going to write the formula. 3 halves is just a number. Now 1 half, I'm going to give him the power of n. And I'm going to write it again, 1 half to the power of negative 1. Now that may seem a little weird. If you were multiplying these, what would you do to those exponents? You would add them together. Right? Do you believe me that these two have the same base? You would add the powers. So if he has 2 exponents, just split them up. This is always the formula, so this is always how it works. Now this one right here is going to get reciprocated. So the next thing that you do, you write 1 half to the n. The number that has the negative 1 power needs to get flipped. If it was just a number, I'd say 1 over, but since it's 1 half, I'm going to flip it and make it be a 2. If it was a negative and I flipped it, it would just be a negative. Okay, this means reciprocate. And now I could take the number times the number, so let's go ahead and clean this formula up. 3 halves times 2, that's just going to make a 3 times 1 half to the power of n. Now I am going for an A this chapter, and I have a formula. I want to see if this is the right formula. Okay? You can check your formulas all the time. So what I'm going to do is take 3. I'm going to multiply by 1/2 to the power of 1. Is that the first term? Yep, that's good. Second, enter. I'm going to change the power to a 2. In fact, I'm going to do math fraction. Did that make the second term? Excellent. Okay, and you can keep checking this to see, does the power of 3 make the third term? Yes, I'm definitely getting an A. This is the right formula for that sequence. All right, let's take a look at the next one. We have, let's see, a negative and a positive, and a negative and a positive. So it seems like they're multiplying by a negative. What you can do to figure out the common ratio is divide two numbers. I think I'm going to try that here. I'm going to take 24/9, divide by the previous, negative 48/27. So you could also take these two down here. So I'm just going to take the first two here and see what I can do. So I'll use my alpha y equals 24/9 is going to get divided by negative 48/27. And maybe I'll math fraction it up. So I think that the r value is negative 3/2. The r value is negative 3/2. Let's see. Let's see if negative 48/27 times by negative 3/2. Is that 24/9? Oh yes, simplified. And let's multiply by negative 3/2 again. Oh, negative 12/3 is negative 4, indeed. And let's do it again. Positive 6. Okay, I am correct. R is definitely negative 3/2. So is this geometric? Yes. The R value is negative 3/2. It's time to write a formula. So how do you get a term for this sequence? Well, you start with the first term, which is negative 48/27. The R value is negative 3/2 to the power of n minus 1. Now, why did they do this? I think they left the numbers like that so you could see the pattern a little more clearly. If you reduced them all, it wouldn't have been so obvious. So negative 48/27 can actually simplify into negative 16/9. I think I'm going to reduce that one just so that my work is a little easier. Okay, remember how we tackled this here? You take the r value, negative 3/2, and you give it the power of n. Then we're going to take negative 3/2 and give it the power of negative 1. Now, the more you do and the better you get, you'll be able to skip this step and just flip it right away. Because if it has a negative power, remember what you have to do? Let's get over there, copy this all down. We're going to flip this, and a negative that's reciprocated is still negative, so it's negative 2/3. One negative sign. Okay, I'm going to put the answer over here. A sub n equals, we have to take this number times this number. So that's going to make a positive 32/27. Then we have negative 3/2 to the power of n. So you may have to do some fraction work there and clean things up a little bit. Okay, looking at this next one. Is this one geometric? If you take one term, take 3, and divide by the previous term, the ratio there is negative 1/3. Is that true? Negative 1/3, negative 1/3, negative 1/3. Yes, this one is geometric. The ratio is negative 1/3. Okay, so the r value is negative 1/3. A sub 1, the first term, oh, it's right there. The first term is negative 9. And A sub n formula. Okay, let's do it again. A sub n is the first term, negative 9, times by r to the power of n minus 1. So what we're going to do here is split this up. Negative 9, negative 1/3 is going to get the power of n, and then it's going to get the power of negative 1, which means you have to reciprocate it. So maybe we'll speed things up here a little bit and say negative 3. Good. So A sub n is going to be number times number. 27 times negative 1/3 to the power of n. And now we have to use that formula to find the 100th term. Let's see if that formula is right before we do any work, though. Let's take 27, then we'll times by negative 1/3. Where's the negative? Negative 1/3 to the power of 3. 1, 2, 3. Oh, made the third term. Perfect. Let's do the same thing and see if it works for 2. Perfect. Okay, so now that I know I have the right formula, I'm going to find the 100th term. So I'm going to make n be 100. 5.24, rounded, times 10 to the negative 47th power. Why is that getting so small? Oh, I see why. These terms are getting tiny, 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 tiny. Okay, for this last example here, we have to see if it's arithmetic or geometric. So does it look like they're adding, adding, adding? Or does it look like they're multiplying, multiplying, multiplying? It looks like multiplying. This is geometric. Geometric, because the r value is negative 5, and a1 is negative 1. Okay, we have to find n. So this is the first term. This is the second term. This is the third term. This is the fourth term, and this is the the a sub, oh, I don't know. This is the a sub nth term. Well, it seems like I might have to make an a sub n formula. And then I have to find n. I need to know, is this the 6th, the 7th, the 8th? Okay, let's go for it. So an explicit formula, a sub n, is a1, which is negative 1. The r value is negative 5 to the power of n minus 1. Now we're going to go ahead and clean that up a little bit. So we have negative 1, negative 1/5 to the n, and the reciprocal of negative 5 is negative 1/5. So the formula is negative, negative, positive 1/5 times negative 5 to the nth power. So here's the formula. And I'm going to use that formula to figure out what number term this is. So why don't we plug this into the a sub n formula? Okay, let's switch colors so you can see I'm doing something else now. I'm going to put 4, 8, 8, 2, 8, 1, 2, 5 into the formula equals 1/5 times negative 5 to the nth power. So the first thing I'm going to do to solve for n is multiply both sides by 5, times by 5, times by 5, and 5 multiplied by 4, 8, 8, 2, 8, 1, 2, 5 is, what'd you get, people? What'd you get here? 244,140,625, I'm hoping, equals negative 5 to the nth power. Okay, a couple ways you could do this. You could do logs, or you could play with your calculator. People usually choose the second option. It does not really matter. You just have to get n. Okay? Could n be a fraction or a decimal? This is the first term, the second term, the third term. Could this be the 11.2986th term? Of course not. N will be an integer. Okay, so that's going to make our guessing a lot nicer. N is an integer. In fact, look at this. A negative 5 raised to a power comes out to be a big positive. So that means, is N even or odd? Okay, N is definitely going to be even. So now it's up to you. I guess we could just guess. We could guess, is negative 5 raised to the 10th power enough? No, not enough. Some people like to go big. They say, okay, well, if 10 didn't work, I'll try 20. Whoa, too big. Okay, remember, you got to guess even, and you got to figure out what makes 244 million. Second enter, I'm going to change 20 to 16. I'd put 15, but that's not an even. Nope, still too big. Let's guess 12. N is 12. So how many terms does this sequence have? 12 terms. And that's geometric for you.